Find the set UC set of function fx, where fx is x times exponential of 2x. So you do the first derivative of this function. First of all, you specify whether this function is fit with 1 to 4 category. Is it fitting with that? X times exponential of 2x. Is it fitting to the special function? Yes, it is. In what? 1, 2, 3, or 4? 4. So that means if you want to find the using set of this function, you got to define first whether you can use this technique with this function or not. If it's not, then you don't need to find the successive terms of it, because it's nonsense to find that, right? So the first derivative of this fx is what? This one is the first derivative of this function. X d exponential of 2x by dx plus exponential of 2x by dx, right? Right, this is the derivative of the product of two functions, right? So you would get what? 2x exponential of 2x plus exponential of 2x, right? So if you do the second derivative of this, you would get this, which is 4x times exponential of 2x plus 4 exponential of 2x. If you don't take a look at the coefficient, if you look at the function only, do you think the function is already repeated? Do we need to do more derivatives? This is the first derivative, and this is the second derivative. Do we need to do further derivative for this? Do we need to do the third derivative of fx? ต้องทำไหมต้องดิฟขั้นที่3ไหมเนี่ยต้องไหมทำไมอ่ะมันซ้ำแล้วก็พอแล้วนะคะ So if you take a look at this closely, you would find that there's only two functions here, which is x times exponential of 2x and exponential of 2x, right? Then you get to write down the UC set of this function. You would get x times exponential of 2x and exponential of 2x. Now, we are going to find the solution of the differential equation, because we already know how to find the UC set of it. The first one is saying that find the solution of this differential equation. The second derivative of y plus 9y is equal to 18x squared. If you take a look at the 18 of x squared, now this is the non-homogeneous differential equation, right? Right? It is non-homogeneous, right? How do you know whether it is homogeneous or non-homogeneous? You look at the fx. If your fx is equal to 0, that means it is a homogeneous. But this one, is your fx equal to 0? No, your fx is equal to 18x squared. So that means this differential equation is non-homogeneous differential equation. So your solution should combine with two parts, which is yc and yp. To find yc, you just set this differential equation equal to 0, or the homogeneous equation of it. And you can find yc by writing down the characteristic equation. What is the characteristic equation of this differential equation? M squared plus 9 equal to 0. So you can find two values of m, which is What is two values, two roots of m? Plus minus 3i. It is the complex root with its conjugate, right? What would be the answer of yc? So the real part is equal to 0, so that means the term of exponential, you got exponential of 0. What is the value of exponential of 0? 1. So you would get only the term inside the parenthesis, which is c1 cos bx plus c2 sin bx. Now what is the value of your b? 3. So you would get c1 cos 3x plus c2 sin 3x. That is your y. Now we are going to find yp. Your fx. If your fx is fitting with the function for the undetermined coefficient, what is your fx? 18x squared. So the function of x squared fits with k1, right? It is fit with the category 1, which is x to the power k, and k is the positive integer. So that means you can use this technique to find yp. To find yp, here is the method to find yp by using the undetermined coefficient method. First, you have to write down the set of UC functions. From the previous example, can you tell me what is the function inside the set of UC function of x squared? X squared, x and 1. Okay. For the procedure first, you got to define first whether your fx is fitting with the function for the UC function. If it is, then second, you got to write down the UC set of your fx function. So in this case, we find already x squared, x and 1. Next, take a look closer whether the function inside your UC set is the same as the function in your yc. Now, what is the function in your yc? What is the function inside your yc? You have what? Cos 3x and sin 3x. What are the functions inside your UC set of function f? X squared, x and 1. So from this you find out that the function inside your UC set is not repeated with any function in yc, right? They are different functions. So in that case, if none of them repeated through your yc function, then you can assume your yp is equal to the linear relation of the function inside your UC set function, which is equal to a1 x squared plus a2 x plus a3. a1, a2, a3 is a constant that we are going to find. So the next step is try to find a1, a2, and a3. The way to do that is just that. Because you know that your yp is the solution of your differential equation. So we are going to put yp back into our differential equation. So in order to put yp in here, you've got to do the derivative of yp for how many times? 2 times, because you have taken derivative of y here. So the first derivative of yp, what do you get? 2a1x times plus a2. And for the second derivative of yp, you would get 2a2. And then you just plug the value of yp and the second derivative of yp into your differential equation. You would get the second derivative of y equal to 2a1. I put 2a1 here, plus 9y. 9 times y, now your y is equal to a1x squared plus a2x plus a3, equal to 18x squared. Now, we are going to rearrange the differential equation in such a way that we can compare the coefficient in front of each function. 2a1 is a constant, so you put 2a1 with a3. Okay. So I just write down it again by x squared, x, and constant. Got 9a1x squared plus 9a2x plus 2a1 plus 9a3. And on my right hand side, although I know that I have only 18x squared, but actually with this side, they have x and x to the power 0 too. But the coefficient in front of that x is equal to 0. So that's why you don't write it down. But this time you got to write down because we are going to compare the coefficients. If this whole thing is true, then that means 9a1 should be equal to 18. And 9a2 should be equal to 0. And 2a1 plus 9a3 should be equal to 0 by comparing the coefficients here. So we got this. And from this, we can get the value of a1, right? Because 9a1 equal to 18, so a1 equal to 2. 9a2 equal to 0, so a2 equal to 0. And 2a1 plus 9a3 equal to 0. We know that a1 equal to 2, then can we find a3? Yes, our a3 equal to minus 4 divided by 9. And that's coming to our yp, because we know that our yp is equal to a1x squared plus a2x plus a3, and now we know the value of a1, a2, and a3. We just plug that number in there, then we know that our yp is equal to 2x squared minus 4 over 9. So the solution of this differential equation is y equal to y3 plus yp, which is c1 cos 3x plus c2 sin 3x plus 2x squared minus 4 over 9.